In this video, I'll talk about how does the density changes with the temperature. The first thing you need to understand, what does the density mean? The density means how much mass you have in a unit, the volume. So if you take a different substances, different materials, exactly the same volume, then the mass would be different. So the density is defined as in a unit volume how much mass you have. The more the mass in a unit volume is, the higher the density is. And that's how we define the density in order to compare one material or one substance to another substance. So the density is denoted by rho and defined as mass per unit volume. Now let's say you have a liquid which is filled in a beaker or in any bottle or something. This is the initial volume. Vi stands for the initial volume. The rho I is the density at that particular temperature, which is Ti, and is the mass. Once you hit this material or when this liquid, then we call the volume changes, and the volume is Vf. That's the volume. The density also changes, and we call the density to be rho f. This is pronounced as rho, R-O-H-O, rho. And this is the notation for the density. The mass does not change. If we have the mass, it doesn't matter where you take it. You take it to the moon, you take it to the Jupiter, you take it to the Saturn. The mass does not change. Because even the temperature changes. The only parameter that changes is the volume and the density. The mass always remains constant. And Tf is the final temperature. So with the increase or with the change in the temperature, the volume changes. The volume expands. And the change in the volume is given by this formula here. And again, how does this coming from? You need to understand the volume coefficient of the material, and the link for the volume expansion coefficient is given below. So the delta V is the initial volume, the beta. This beta here is the volume expansion coefficient, or you call the coefficient of volume expansion. And delta T is the change in the temperature. What is this delta V again means? The delta V means the change in the temperature, which is the final temperature minus initial temperature. That's how we call the change in temperature. So I'm simply writing Vf minus Vi, and this term is exactly the same term here. So I'm solving for Vf. So the Vf will be, if I take to the other side and take Vi out, it will be 1 plus beta delta T. So the density at this temperature, at the final temperature, how do you define the density at this temperature? Again, how much mass you have and what's the volume. So you get the mass per unit volume, and this volume is at the final temperature. The mass as it is, because mass does not change, and the volume is now given by this equation, Vi times 1 plus beta delta T. This is exactly the value I plugged in here. Okay, so the mass per unit Vi is now the density at the initial temperature that we call rho I, and this term is exactly as it is. So this is now an equation or an expression for calculating the density with a change in the temperature. And what you have to notice here, it only depends on one parameter, that is the beta, which is the coefficient of volume expansion. For most materials, if you look at the most materials, the density decreases with the increase in temperature, because for most materials the beta is positive, it's greater than 0, but not for all materials. There are certain materials, or there are materials whose beta, or the coefficient of volume expansion, is negative within a certain temperature. Within a temperature regime, it is negative. And the water is the one interesting example. If you look at the water has such a peculiar the coefficient of volume expansion, and between 0 degrees to 4 degrees Celsius, the coefficient of volume expansion for the water is negative. And that has played such a vital role on the survival of many animals inside the lake, inside the pond, inside the ocean. And this is due to this region, the water has the greatest density at the 4 degrees Celsius. Let me explain one thing. For water between 0 degree to 4 degrees Celsius, if we increase the temperature, the the beta is negative. That means the density increases. If you go from 0 to 4 degrees Celsius, the density increases, and the maximum density of water is at 4 degrees Celsius. So even if the lake is frozen, entirely frozen, at the bottom, it has to be the liquid water, because the liquid water has the greatest density or occupies the maximum density, and the densest material always sinks at the bottom. So with this example, you might have understood now. Even the lake is frozen. Why do the fish or the animals survive inside the frozen lake? Because deep inside the frozen lake, there is the liquid water, and that might be the 4 degrees Celsius. So remember this formula to calculate how does the density changes with the temperature. This is it from this lecture. Again, if you have any questions regarding how does the density changes with the temperature, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.